Okay, let's unpack this a bit. Think about those big strategic decisions you face.
Mm.
For your team, your company, maybe even just your own career path. How often do we just go with a gut feeling?
Right, or maybe rely on data that only tells us what already happened.
Exactly. The world's just moving way too fast for that approach now.
It really is.
Welcome to the deep dive. Today, we're taking a plunge into something really crucial: strategic analytics and decision intelligence.
Yeah, this is a fascinating area.
We're pulling insights from what feels like a foundational chapter from a really cutting-edge resource in this space.
It definitely sets the stage well.
And our mission for you, the listener, is to explore how this whole world of strategic decision-making is shifting, moving from, let's say, pure intuition
Mm.
towards these incredibly sophisticated, data-driven models. Think of this as your shortcut to getting really well-informed.
Understanding the tools, yeah.
Understanding the tools that let organizations ask smarter questions, find those hidden patterns, and, crucially, respond dynamically as conditions shift.
And it really boils down to a powerful truth, doesn't it?
Then,
Data is not strategy.
but without it, strategy is just guessing with confidence. I love that quote.
It captures it perfectly. You need both.
It really does sum it up. And as we navigate this deep dive, we're going to touch on some genuinely surprising real-world examples.
Oh yeah, some really compelling ones.
We're talking about how a major financial services company, completely re-engineered its strategy using AI,
That's a big one.
and how those classic strategic tools that, many of us learned, they're getting this powerful upgrade.
Right, they're not obsolete, they're evolving, becoming
Oh.
dynamic living systems.
Exactly. So to really get why this transformation is so critical right now, maybe we should first look at why strategic decisions so often fail when they lack this intelligence piece.
That's the right starting point. Traditionally, strategy often felt a bit like navigating with a foggy map, wouldn't you say?
Definitely. You had periodic reviews, maybe annual planning cycles.
Heavy reliance on expert judgment, looking mostly at historical data,
Right. All assuming a world that was, well, pretty stable.
which is, let's be honest, sounds almost quaint today.
Totally quaint. We're operating in this incredibly dynamic, data-rich landscape. You've got volatility, digital disruption everywhere.
And these incredibly complex interdependencies. It's not checkers anymore.
No, it's like that two-dimensional chess game has become a fast-paced, multi-dimensional simulation.
Well put.
Mm-hmm.
And without decision intelligence, companies stumble into some really common, really dangerous traps.
Like what are the big ones?
Well, one of the biggest is probably overconfidence in historical success. Companies assume what worked before.
We'll just keep working.
Exactly. Think about Blockbuster. They just couldn't see Netflix coming.
Right. Was it a lack of vision or something else?
I'd argue it was, fundamentally, a lack of the right data capabilities. They couldn't recognize those crucial behavioral shifts happening right then.
They were stuck looking in the rearview mirror.
Well, the future was speeding right past them. Yeah.
And you mentioned the failure to anticipate interactions. That sounds like it's not just missing one link, but the whole chain reaction.
Oh, absolutely. It's the cascade effect.
Mm.
Strategic decisions are rarely linear, are they?
No, never simple.
So a pricing change, for instance, it doesn't just affect revenue directly.
Right, or ripples out.
It can hit customer loyalty, strain your supply chain, change brand perception, all simultaneously, maybe in ways you didn't expect.
So without the tools to model that?
Like, say, partial dependence plots or even digital twin simulations. You're essentially just guessing at those ripple effects, hoping for the best.
Which is risky. And then there's neglecting those low probability, high impact risks, the black swans.
Exactly. The 2008 financial crisis, COVID-19, obviously, the big supply chain breakdowns we've seen.
Yeah.
These remind us that improbable events can have absolutely catastrophic consequences.
And things like Monte Carlo simulations can help quantify that.
They can. They give you a probability distribution of outcomes. But without them, firms often fall back on these overly optimistic best-case assumptions.
Leaving them incredibly vulnerable when reality bites.
Precisely. And think about static analysis in a dynamic world. Frameworks like SWOT or VRO, they're useful, no doubt.
Sure, classic tools.
But if you only dust them off once a year, they get stale fast.
They lose relevance.
Predictive analytics, real-time assessments, these can transform those static snapshots into live, evolving dashboards, always reflecting the current reality.
And what about human bias? That's always lurking, isn't it?
Always. And it's not usually malicious. It's just human nature, right? Executives, all of us, filter information through our own experiences, our beliefs,
Confirmation bias is powerful.
incredibly. But decision intelligence systems, when they're designed well, can actually surface those contrarian patterns. They can challenge intuition with hard evidence.
So it expands your judgment, gives you a clearer lens.
Exactly. It doesn't replace judgment, it enhances it.
Okay, so if traditional strategy was that foggy map, decision intelligence is like turning on the strategic GPS.
With live satellite feeds, yeah.
It's no longer just a support function or a department down the hall. It's becoming the operating system for smart ionizations.
That's a great way to put it, an operating system.
And this strategic GPS, it seems to have 4 critical components based on the reading. First, sensing.
Right. Sensing is about detecting those faint signals, often buried in mountains of unstructured data. Think social media, news feeds, customer reviews.
Using things like natural language processing to pick them out.
Exactly. Then there's sense-making. This is about interpreting patterns from all that noisy information, turning data into actual insight.
And that's where tools like XGBoost and SHG values come in.
Precisely. They help you understand not just what is happening, but why.
Okay, sensing, sense-making, then simulation.
Simulation is huge. It's about forecasting outcomes before you commit.
Testing the waters digitally.
Yeah, using tools like Monte Carlo again, or digital twins, to run what-if scenarios. Testing different strategic moves under various conditions without that real-world risk.
That sounds incredibly valuable. And the last piece.
Learning. Intelligence really compounds when organizations treat every decision, every outcome, as a data point.
Building a feedback loop.
Yes, a continuous learning infrastructure,
Yeah.
reviewing model performance, updating assumptions. It's about getting smarter over time.
This leads us to what feels like a really crucial shift then. Moving beyond just pattern recognition
Which is what strategists have always tried to do.
to actively engaging in pattern simulation. Can you unpack that difference?
Sure. A traditional strategist might recognize a trend, right?
Yeah.
Let's say a broad consumer shift towards sustainability. They see it happening.
Okay.
But a strategist armed with simulation tools, they go much, much further. They can actually model how different levels of investment in sustainability might influence market share, customer loyalty, maybe even regulatory exposure under lots of different possible future conditions.
So they're exploring thousands of potential futures, essentially.
Exactly. It's like stress testing your strategy in a virtual world before you launch it in the real one.
Wow. So it transforms strategy from just observing.
Into a dynamic experimental science.
Mhm.
Instead of just seeing what is happening, you're actively testing how things will evolve and respond to your choices.
That gives you an incredible edge.
A massive edge.
Okay, so moving from these core ideas to more concrete action, let's talk about the analytics continuum. This progression sounds key.
It is. It's a way to think about how analytical capabilities build on each other, taking you from understanding the past to actually prescribing future actions.
So it's starting at the base.
At the base, you have descriptive analytics. This answers the simple question: what has happened?
The rearview mirror.
Exactly. Summarizing historical data, giving you clarity. Think dashboards, KPIs, standard reports.
Like the Intel example, using factory dashboards to monitor efficiency.
Precisely.
Mm.
It tells you what occurred very clearly, but it doesn't necessarily tell you why or what to do next.
Right. So we've understood what happened. The next step is peering into the future.
That's where predictive analytics comes in. This tackles the question, what could happen?
Looking around the corner.
Yes. Here, you're leveraging historical data plus sophisticated statistical models to forecast future outcomes.
And this is where machine learning models like XGBoost you mentioned really shine.
Absolutely. They help you anticipate demand, predict which customers might churn, forecast financial shifts.
Like Spotify predicting listening patterns to guide their investments.
That's a perfect example. The challenge here, though, can often be interpretability.
Meaning understanding why the model made that prediction.
Exactly. Without specific tools designed for explainability, like SHA or PDPs we'll get to, it can sometimes feel like a black box.
Okay, so descriptive tells us what happened, predictive tells us what might happen. What's the final step?
That's prescriptive analytics. This answers the ultimate strategic question. Okay, so what should we do about it?
Moving from insight to action.
Yes. Its purpose is to actively recommend the actions most likely to deliver the outcomes you want, while balancing all those complex trade-offs and goals.
And this involves even more advanced techniques.
Right. Things like Bayesian optimization, Monte Carlo simulations again, digital twin simulations. These models don't just predict, they optimize and recommend.
The UPS Orion system is a classic example, prescribing the best routes.
It is literally telling drivers the optimal sequence of stops to save time and fuel across their massive network. It's prescriptive in action.
What's really powerful, it sounds like, is integrating these levels, not seeing them at separate steps.
Absolutely. It's most powerful when it becomes a continuous loop, moving organizations away from rigid, maybe annual planning cycles.
Towards a living, breathing system of analytics-powered decisions that are happening much more frequently.
Constantly anticipating what's next, and dynamically exploring the best actions to take. It's a fundamental shift.
So we've covered the why this intelligence is needed, and the continuum from description to prescription. Now, I'm really curious about the how. What are the actual tools in this strategic analytics toolbox?
Okay, let's dig into the toolkit. And these aren't just, generic statistical methods. They're really strategy-enabling engines designed for specific strategic jobs.
Okay, strategy enabling engines. I like that. What's first?
First up, let's talk XGBoost. You can think of this as the ultimate predictive engine for strategy.
Why XGBoost specifically? What makes it special?
Well, it's a type of gradient boosting algorithm, and it's known for exceptional accuracy, speed, and robustness, especially with messy, real-world, nonlinear data.
How does it work in simple terms?
Imagine building thousands of small, simple decision trees, but each new tree focuses on correcting the errors made by the previous ones. They learn together, iteratively.
So it gets smarter as it goes.
Precisely. Its strategic value lies in handling diverse data types, complex nonlinear relationships, and large data sets really well. It's like a predictive microscope.
For answering questions like, which markets will yield the highest return?
Or which customers are most likely to churn? What features predict product success? That kind of thing.
Got an example?
Yeah. A global logistics firm uses XGBoost to forecast delivery delays. They feed it data on weather, geopolitics, fleet conditions, you name it,
And it predicts potential delays.
allowing them to make real-time road adjustments, proactively managing disruptions.
That's incredibly powerful for prediction. Okay, what about when the goal isn't just prediction but optimization, especially if testing things out is expensive or you don't have tons of data?
That's the perfect scenario for Bayesian optimization, or BO. Think of it as intelligent exploration for strategic decisions.
Intelligent exploration. How so?
It's a smarter, faster, and much more data-efficient way to find optimal solutions, especially when testing each option is costly, or maybe the underlying function you're trying to optimize is unknown, like customer response to a new feature.
So it learns as it goes, trying things out strategically.
Exactly. It cleverly balances exploration, trying out new, uncertain areas that might be good, with exploitation refining solutions in areas it already knows are promising.
So its value shines when data is scarce or expensive.
Yes, or the solution space is huge and nonlinear, or you've got multiple competing trade-offs to balance. It guides your experimentation intelligently.
Can you give a practical example?
Sure. Imagine a SaaS company trying to optimize its pricing across different global regions. Testing lots of price points everywhere is risky and slow.
Right.
They could use BO to find the best regional price points with minimal trial and error, maybe finding higher profitability faster without annoying customers or overexposing the brand with constant changes.
Okay, so XGBoost predicts, BO optimizes, but these models sound complex. How do we actually trust them, especially for really big strategic calls? How do we know why they're recommending something?
That is a critical question, and the answer often lies in SHAP, which stands for Shapley Additive Explanations.
SHAP values, I've heard of those. What do they do?
SHAP is grounded in cooperative game theory, specifically Shapley values. It's not just about explaining AI, it's about building fundamental trust in your models.
Wow.
It quantifies exactly how much each input variable, each feature, contributed to pushing a specific prediction for an individual case away from the average prediction.
So for one specific customer, it can tell me why the model predicts they'll churn.
Precisely. It breaks down the prediction. This brings incredible clarity and accountability. It's essential for model auditing, for digging into root causes, for personalizing strategy, and crucially, for building executive confidence.
They need to understand the why.
Absolutely. There's a global insurance firm, for instance, using SHAP to explain exactly why certain policyholders are predicted to file claims. That understanding lets them refine pricing much more accurately and develop targeted risk mitigation strategies.
That's a game changer for transparency. Okay, what about understanding the overall sensitivity of a strategy or a model? Like, if I tweak this one input variable, how does the prediction generally change?
For that, we often turn to partial dependence plots, or PDPs. Think of these as your strategic simulation dials.
Simulation dials, I like that.
Yeah. They let you virtually twist one variable, let's say marketing spend, or the price of a product, while holding all other variables constant, and see how it alone impacts the model's average prediction.
So it isolates the effect of that one factor.
Exactly. It shows you the marginal effect. It answers questions like, how much does this specific variable really matter? Or what happens to our predicted outcome if we change this one thing?
Helping you test sensitivity, quantified trade-offs.
Or maybe even identify nonlinear tipping points where a small change suddenly has a big impact.
Any examples come to mind?
A university admissions office might use a PDP to see how predicted enrollment changes as they increase scholarship amounts.
And they might find.
They might find that the positive effect on enrollment increases sharply up to, say, $5,000, but then the curve flattens out significantly. More money beyond that yields diminishing returns.
That's incredibly useful for optimizing budgets. Okay, PDPs show individual factor effects, but strategy is drenched in uncertainty, multiple factors moving at once. How do you plan for that range of possibilities?
That's where Monte Carlo simulation comes back into play, specifically for modeling uncertainty and building strategic resilience.
We mentioned it for risk, but how does it work in strategy more broadly?
Monte Carlo doesn't give you just one forecast. Instead, it runs your strategic model thousands, maybe millions of times. Each time, it plugs in slightly different values for your uncertain input variables based on their probability distributions.
So it plays out tons of different possible scenarios.
Exactly. Super fast. It shows you the full range of potential outcomes, best case, worst case, and everything in between, and importantly, the probability of each outcome occurring.
So it turns uncertainty from a vague fear into something quantifiable.
Precisely. It helps you quantify risk, stress test your core assumptions, and build robust contingency plans. A solar energy firm, for example, might model the ROI of a new project under thousands of variations in future weather patterns, equipment costs, and government incentives.
Giving them a much richer picture of the potential returns and risks.
A much more realistic picture. Or a consumer goods company could model profitability variations based on fluctuating consumer sentiment, supplier reliability issues, and volatile freight costs.
Okay, that handles broad uncertainty. What about simulating an entire complex system, like a whole supply chain or a business unit, in a really dynamic way?
For that level of complexity and dynamism, the big tool is digital twins. This is about simulating strategy within a living system.
A digital twin, what exactly is that?
It's essentially a virtual, dynamic, data-driven replica of a real-world system. It could be a factory, an entire supply chain, a specific market, or even a whole enterprise.
And it's connected to the real thing.
Yes, that's key. It continuously receives real-time data from its physical counterpart, so the twin evolves and changes, just like the real system does.
Wow. So what's the strategic value?
It allows for completely risk-free scenario testing on a grand scale. You can understand complex, systemic ripple effects. You can align long-term strategy with fast-changing realities. It essentially lets you rehearse major strategic moves before you make them in the real world.
Rehearse strategy, that's powerful.
Imagine a global port authority. They might use a digital twin of their entire logistics ecosystem, ships, trucks, cranes, storage, to test different expansion strategies or simulate how they'd respond to major disruptions, like a storm or a labor strike.
Finding bottlenecks or vulnerabilities before they happen.
Exactly. Or a global hotel chain could create a digital twin of its key markets to simulate the impact of things like green investments, dynamic pricing strategies, or new loyalty programs on occupancy and profitability.
That's quite a comprehensive toolkit. XGBoost, BO, SHAP, PDPs, Monte Carlo, digital twins. It's crucial to remember these aren't mutually exclusive, right? They work together.
Absolutely. They are highly complementary. The right tool, or combination of tools, depends entirely on the specific strategic question you're asking.
And the data you have, the urgency.
The level of uncertainty, the need for explainability. If you need top-tier prediction, think XGBoost. Need to optimize with limited data, maybe BO. Need clarity and trust. Pair your model with SHAP and PDPs.
Planning for a wide range of futures, Monte Carlo.
Simulating complex system dynamics. Digital twins. It's about building a versatile analytical arsenal tailored to your strategic needs.
Now, this is really interesting, the idea of reinventing classic strategy frameworks using these analytics tools. The concept isn't to throw out things like VREO or SWOT.
Not at all. It's about augmenting and reimagining them, taking them from often static qualitative checklists.
Into dynamic, data-driven living systems powered by algorithmic insight.
Exactly. Take VRIO augmented with SHAP, for example. VRIO traditionally asks if a resource is valuable, rare, inimitable, and organizationally supported.
Right, often a subjective assessment.
But now we can move towards quantifiable, real-time measurement. SHAP can help explain to what extent a specific resource or capability truly contributes to performance outcomes, like profitability or net promoter score. That quantifies value.
And for rarity or imitability.
Data analysis can benchmark how unique your capability actually is compared to competitors, maybe by scanning patents or competitor job postings. It makes it less guesswork.
And organization, how does analytics help there?
SHAP can be really insightful here. It can show if a valuable resource's impact is conditional on other factors being in place. For example, maybe your advanced analytics capability only delivers real value if you also have data-literate middle managers who know how to use the insights.
It reveals the necessary combinations.
Yes. There's a great example of a fast-growing omnichannel retailer. They used SHAP and found their AI-powered pricing engine was a huge driver of profitability. That's the V's.
Okay. But A-Shape also showed this was only true when it was paired with high mobile app adoption among customers. The engine needed the app data to work its magic.
Ah, so that revealed the organizational context needed.
Precisely. It led them to a truly data-driven VRIO scorecard that wasn't just a snapshot, but something that evolved, showing them where their advantage truly lay and how to nurture that specific combination.
That's fascinating. What about SWOT analysis? Strengths, weaknesses, opportunities, threats? That often feels very static and subjective.
It often is. But SWOT, augmented with predictive trend data, transforms it. It shifts from being static, subjective, and backward-looking.
To being dynamic, evidence-based, and crucially forward-looking.
Instead of just saying a strength is a strong R&D team,
Which is vague.
a predictive SWOT might say something like, strength, patent output forecasted by our model to grow 18% year over year, significantly strengthening our IP position relative to key competitors whose filings are flat.
Much more concrete and future-oriented. Exactly. But doing this requires pulling in robust, diverse data sources for every single quadrant.
Not just internal data.
No, structured and unstructured, real-time feeds if possible, quantitative and qualitative data, internal and external market signals.
And then you use predictive models.
Right. Models like XGBoost or time series forecasting can assign probabilities and potential magnitudes to external forces, the opportunities and threats, like forecasting the likely financial impact of new carbon taxes on your operations, or predicting a surge in demand from Gen Z travelers next year.
So the output isn't just a 2x2 box anymore.
Ideally, no. You should envision it more like a live dashboard. Data feeds updating constantly, maybe quadrant scores changing, confidence bands around forecasts, even scenario switchers allowing you to explore what-if situations for key threats or opportunities.
That's a radically different way to think about SWOT. And environmental scanning, how does that change?
It also gets a massive upgrade, moving from often passive monitoring to intelligent sense-making, powered by machine learning and natural language processing.
So instead of analysts manually reading news and reports,
Which is slow, prone to bias, and often misses connections because information is siloed. ML and NLP can automate the ingestion of vast amounts of text.
from news articles, social media, scientific papers, regulatory filings.
Millions of documents.
Yeah.
And then apply techniques like entity recognition, finding mentions of companies, people, products, topic modeling, discovering underlying themes, sentiment analysis, gauging opinion, and anomaly scoring, flagging unusual shifts.
This helps tackle the information overload problem.
Exactly. It shifts you from drowning in noise to actually detecting strategic signals. It's about finding those weak signals buried in the data. Maybe an uptick in academic papers on a new technology combined with venture capital funding announcements in the same space.
Seeing connections across domains.
Yes, detecting that cross-domain convergence where seemingly unrelated trends start to collide. Predictive topic modeling, using techniques like LDA or BER topic, can uncover abstract themes emerging in research or public discourse before they become mainstream.
And competitive intelligence gets a boost too.
Huge boost from open source intelligence, or OSINT. Using web scraping and NLP to systematically track competitor activities, analyzing job postings for hiring trends, monitoring patent filings, tracking app updates, dissecting investor briefings.
So if a logistics company notices a rival suddenly hiring dozens of ML engineers specializing in routing algorithms and filing related patents.
That's a real-time, data-driven strategic signal about their likely future direction, much more powerful than just reading their annual report.
Okay, one more classic concept, strategic fit. That alignment between the company and its environment. How does analytics model that?
This is perhaps the most holistic application. Strategic fit as a modeling problem. Traditionally, fit was more of a conceptual ideal, something you aimed for intuitively.
Right, does our structure support our strategy? Do our capabilities match the market?
Now, analytics allows us to map, measure, simulate, and even optimize that fit using a systems thinking approach.
How do you map it?
You can start by constructing a multidimensional blueprint of the organization. Its key resources, capabilities, value propositions, core activities, market positions. Then, maybe use network analysis to model the interconnections between these elements.
Identifying dependencies, potential bottlenecks, or points of leverage within that system?
Exactly. And you can model fit across different layers of strategy. Corporate level fit. Does our portfolio of businesses make sense together? SHAP could help analyze contributions. Business level fit is our competitive positioning right for the market. PDPs could test sensitivity. Functional level fit are marketing and R&D aligned. Causal loop diagrams might model that. And even temporal fit is our strategy consistent over time. Time series analysis helps there.
That's incredibly detailed, but the real test is under pressure, right?
Absolutely. The crucial step is then simulating strategic fit under various stress scenarios, using Monte Carlo, digital twins, or system dynamics models.
You can observe how well that alignment, that fit holds up or potentially fractures when confronted with shocks.
Like an economic downturn, a major competitor move, or a supply chain crisis. You could simulate a large retail transformation, for instance, and see its holistic impact, not just on sales, but on logistics, brand perception, employee morale, uncovering potential misfits before they become costly, real-world problems.
And these fit models aren't just for finding problems, they can find opportunities too.
Yes, that's a key point. It's not just about fixing misalignments. These models can reveal opportunities for amplification, where small, targeted changes might yield surprisingly large positive results.
Like finding unexpected synergies between resources.
Or identifying a critical capability bottleneck where improvement would unlock value across the system. Or finding areas where cultural alignment strongly boosts performance. Methods like sensitivity analysis with PDPs or using SAP to map contributions can pinpoint these hidden zones of strategic leverage that might be totally invisible otherwise.
Okay, this is immensely powerful. But with all this power to predict, optimize, and simulate comes, well, a huge amount of responsibility.
Absolutely. That brings us squarely to ethical intelligence in strategic modeling. This isn't just a nice-to-have or a compliance checkbox.
No, it sounds like it has to be core to the strategy itself for long-term success.
It's a strategic necessity. At its heart, it's about proactively addressing bias, ensuring transparency, and embedding responsibility deep into how these powerful models are built and deployed.
Let's talk bias first. How does that creep in?
Bias can inadvertently enter models at so many stages. The data you collect might reflect historical societal biases. The features you choose to include or exclude can encode bias. Even the design of the algorithm itself can have biased outcomes.
Can you give examples?
Sure. A hiring model trained predominantly on historical data from a non-diverse workforce might learn to favor candidates who look like past hires, unintentionally screening out qualified, diverse applicants.
Or a loan approval model.
Could inadvertently learn proxies for protected characteristics like race or gender, even if those aren't explicit inputs, leading to discriminatory outcomes. Or even an innovation scoring model might be biased towards incremental improvements over truly novel ideas if that's what the training data reflects.
So ethical intelligence means actively looking for and mitigating this.
Continuously, building in practices for bias auditing, fairness checks, and mitigation strategies right from the start, and monitoring them over time.
Okay, bias is one pillar. What about transparency? We touched on SHAP.
Transparency is crucial for building trust, both internally with decision makers and externally with customers, regulators, and the public. Tools like SHAP, but also just clear model documentation and visual explainability tools like PDPs.
They allow people to understand why a model is making a recommendation, not just blindly accept the output.
Exactly. It moves it from a black box to a glass box. That transparency isn't just ethical, it's a strategic asset. It fosters adoption and accountability.
And responsibility. What does that entail?
Responsibility means ensuring humans remain meaningfully in the loop, especially for high-stakes decisions. It means having clear accountability chains, who is responsible if a model makes a harmful decision. It involves setting up thoughtful, ethical review processes or boards to anticipate potential harms beyond just the immediate business metrics.
Thinking about second and third order effects.
Precisely, the potential impact on jobs, communities, fairness, the environment.
Because without this deliberate ethical lens, focusing solely on short-term optimization can lead to some really damaging long-term consequences.
Right, we see several potential risks. One is strategic lock-in. Models trained on past data can sometimes just reinforce the status quo, making the organization resistant to necessary change or innovation.
Like a retail algorithm that keeps favoring existing best-selling products?
And effectively starves the company's pipeline for genuinely new or disruptive products because they don't fit the established pattern. They're structural drift. This is where increasing automation distances leaders and decision makers from the messy realities on the ground.
Losing touch?
Yeah. An airline might optimize pricing perfectly using an algorithm, but if that system doesn't capture rising customer frustration from other sources, leaders might miss crucial signals until it's too late. They lose that nuanced, qualitative feel.
Ethical drift.
That's where the relentless pursuit of efficiency or optimization starts to subtly pull the organization away from its stated values or ethical principles.
How might that happen?
Maybe a talent retention model, optimized solely to reduce attrition costs, inadvertently learns patterns that disadvantage caregivers or older workers, even if that wasn't the intent. The model drifts away from fairness principles.
I see. These are subtle but dangerous.
Very. Then there's ecosystem distortion. Automate strategies deployed at scale by one or multiple companies can ripple outwards, affecting competitors, customers, suppliers, even regulatory frameworks in unforeseen ways.
Like dynamic pricing algorithms across an industry leading to price homogenization and maybe reduced overall market resilience.
That's a potential example, yeah. And finally, reputational fragility. Automation, lacking human empathy and contextual awareness, can sometimes make decisions that seem logical by the numbers, but are completely tone-deaf.
Like the example of a hotel AI automatically hiking prices sky high during a local natural disaster because demand surged.
Exactly. Algorithmically sound, perhaps, but reputationally catastrophic. Leads to massive public backlash.
So building strategic accountability with these tools requires deliberate design choices.
Absolutely. It means things like ensuring transparent decision logic is built in, maybe using SHE to generate explanations for every significant automated decision, like financial loan approvals.
Having humans in the loop.
Yes, embedding ethical fail-safes with clear human oversight, especially for irreversible or high-impact decisions. Think cross-functional ethics boards, reviewing plans for things like major layoffs or facility closures that were informed by models.
What about tracking decisions?
Crucial. Implementing traceable strategy through strategic memory systems, detailed records of which models were used, what parameters, who reviewed and signed off, allowing for audits and learning from mistakes.
And involving more people.
Inclusive model governance is key, expanding the range of stakeholders who have a voice in how models are designed and used. Maybe a public transport authority consulting community groups on how a predictive maintenance model might impact service equity.
And finally, designing for scrutiny.
Designing systems to be inherently auditable, ready to withstand rigorous external scrutiny from regulators or auditors. Perhaps Monte Carlo simulation used for capital reserves has a built-in audit layer, explaining its assumptions and distributions.
It really drives home that ethical intelligence isn't a constraint on strategy.
No, it's the compass. It's what guides the power. It transforms powerful analytics from just being clever
into being wise, into sustainable strategy, making it credible, inclusive, and ultimately future-proof.
It allows you to build not just a smart strategy, but a good one.
We have definitely covered a lot of ground today. I really hope this deep dive has helped show you, our listener, how strategic analytics is evolving. It's not just a back-office reporting function anymore.
Not at all. It's become this generative, anticipatory, and, as we just discussed, ethically grounded force for navigating the sheer complexity we all face.
The future strategist, it seems, is less about being a static planner crafting 5-year plans.
And much more about being a real-time sense maker, a designer and conductor of intelligent systems.
Yeah. We truly saw how analytics doesn't just support strategy, it can utterly transform it. That famous story about Zara's strategic agility comes to mind.
Oh, yeah, they're a classic example of integrating this thinking.
Yeah.
They didn't just, guess at which new product lines might work based on last season.
No, they use tools like XGBoost to simulate potential profitability for thousands of designs.
Used SHEP values or similar techniques to understand why certain attributes were driving predicted success, making the rationale transparent.
Used partial dependence plots to visualize, say, how different fabric cost would likely impact demand curves.
Ran Monte Carlo simulations to understand the range of financial risk involved with launching specific collections,
And they've famously built systems that act almost like digital twins of their supply chain and demand signals.
allowing them to make incredibly fast, data-informed, testable, and explainable decisions about what to produce and ship, sometimes in near real time. That's analytics transforming strategy in action.
It really is about moving beyond just what happened to asking what could happen, and based on that, what should we do about it?
And doing so not just smartly, but responsibly.
So, the final thought for you as you navigate your own decisions, big or small, how might you begin to integrate a bit more of this intelligent foresight into your daily choices? How can you move beyond reacting to what's happened towards anticipating what could be and shaping it both smartly and responsibly?
That's the journey these tools enable.
We hope this deep dive helps you explore that question.